Hello, welcome to our third factoring review video. In this video, we will look at factoring polynomials that contain perfect squares or perfect cubes, and we will also go over a general strategy for factoring. So let's start with talking about perfect squares. These are numbers that you get when you take a number times itself. So, for example, we have number 1 in our list here. 1 is a perfect square because when you multiply 1 times 1, it's equal to 1. Or maybe you want to think of it as when you square 1, you get 1. So 4 is 2 times 2. 9 is 3 times 3. And of course, we could keep going down through the list. And that's actually how we came up with this list, is just by squaring 1, squaring 2, squaring 3, and so on. Of course, we could keep going past 100, but you should at least have these numbers that are on the slide memorized so that when you see them, you recognize them as being perfect squares. Now, another term that we will use is square root. So, if I wanted, let's just say, the square root of 9. Sorry, to put a T there. Square root of 9 is 3. The square root of 4 is 2. The square root of 25 is 5. Whatever number you square in order to get this list right here would be considered the square root. Now, we also want to think about variables. So look on the right side of the screen, and you see a list of variables. Notice all of the exponents, 2, 4, 6, 8, are multiples of 2. So you could keep going and make a bigger list, x to the 10th, x to the 12th, x to any even power. Or maybe you want to think of it as x to a power that is a multiple of 2. Those are considered perfect squares. If we think about why they're perfect squares, it's because x squared is x times x. X to the 4th is x squared times x squared, and so on. And we could also use the term square root. We could say the square root of x squared is x. The square root of x to the 4th is x squared. So now that we have an idea of what perfect squares are, let's think about polynomials that have 2 terms in them, only 2 terms, and both terms are perfect squares. Okay, so on this slide, we're writing it as a squared plus b squared. We're saying this first term is a perfect square and this second term is a perfect square. Now, by using the term sum, that means we're adding. Well, it turns out that when you add 2 perfect squares, you cannot factor it. It is called prime. There is no way that you can write it as 2 polynomials multiplied together. So look at this example, x squared plus 25. If we tried to factor that like this, maybe we might think, okay, well, I should put a 5 here because 5 times 5 is 25, and I should put some addition signs in. Well, let's check what happens if we multiply that. We would get x squared plus 5x plus 5x plus 25. And we combine like terms, that would become a 10x, which is not equal to x squared plus 25. And we could try some different things, but no matter what we try to multiply together, we are never going to get x squared plus 25. So that is why it is prime. So just try to remember, if it's a sum, if it's addition between your perfect squares, you cannot factor it. But if it is a difference, so you've got subtraction between your perfect squares, you can factor it. And these are very easy to factor. It factors into two binomials. So you're going to take the square root of the first term and it goes in the front of each set of parentheses. You take the square root of the second term and it goes in the back. And the signs will always be one positive, one negative. They'll always be different signs. It doesn't matter which sign you put first. So look at these examples. So number 9, I'm going to look at my two terms and I'm going to ask myself, are they perfect squares? So x squared, yes, is a perfect square. 144, yes, is a perfect square. We didn't make our list that long a moment ago, but 12 squared is 144, so it is. They're both perfect squares and they have a minus sign. So we're going to factor it by making two sets of parentheses, kind of like we did with the trinomials. And we take the square root of x squared, which is x, and we put that in the front. And we take the square root of 144, which is 12, and we put that in the back. And we're going to put in one plus sign and one minus sign. Again, it doesn't matter which you put first. And that is it. That is how you factor a difference of squares. Let's go ahead and check that one real quick. We won't check all of them, but just so that we can see that it does work. I'm going to switch to black and show our check here. So if I were to FOIL, I would do first x times x. Outside would be a negative 12x. Inside would be a positive 12x. And last, minus 144. Combine the middle terms, which would equal 0, and you'd get your x squared minus 144. So it works. Let's try number 10. We'll go back to red to work that out. We look at the first term and we see 81 is our coefficient. It is a perfect square. It's attached to that x to the fourth there, but x to the fourth is also a perfect square. 1 is a perfect square. And we've got our sign that we need, which is minus. So we're going to make our parentheses. We're going to square root the first term, which involves square rooting the number and the variable. So square root of 81 is 9. Square root of x to the fourth is x squared. So you're going to put 9x squared in the front. And then we look at our 1. The square root of 1 is 1, and that's what goes in the back. Signs are different, 1 plus, 1 minus. So we have factored it, but once you do that step, you always want to check to see if you can factor further. Notice that 9 and x squared are both perfect squares, and 1, of course, is still a perfect square. So if both terms are perfect squares and you've got a minus sign, you have a difference of squares. So this second factor needs to factor further. Now over here on our number 9 example, we didn't factor further because x was not a perfect square and neither was 12. But on number 10, we do need to go further. Remember, when it's addition, it cannot factor. So that 9x squared plus 1 just comes down. We can't leave it off. It's still in the answer, but it just comes down. Then this one with the minus needs to factor. So we take the square root of 9x squared is 3x, put it in the front. The square root of 1 is 1, put it in the back. And we do a plus and a minus. Now let's look at the one with the minus sign again, because that's the only one that could go further. However, 3 and x are not perfect squares, therefore it cannot go further, and this would be our answer. So remember to always check, do I have another difference of squares, in which case I need to factor further. So you can also have what's called perfect square trinomials. To be one of these, the first term must be a perfect square, the last term must be a perfect square, and the last sign must be positive. So if it meets those three conditions, then you might try to factor it using the square roots. It's often quicker to do that than to do the AC method that we learned in the previous video. However, if you do it this way, you must check your answer because it's possible that it doesn't work. If it does, it's nice and short, a great way to do it. Just always check. So let's look at these examples. Factor each perfect square trinomial. So looking at number 11, we see that the first term is a perfect square, the last term is a perfect square, and the sign in front of the last term is positive. So it meets those three conditions. The middle term, notice, does not have to be a perfect square. So we are going to go straight to our parentheses. We are going to put the square root of 25x squared in the front, 5x, and the square root of 49 is going to go in the back, 7. Now we're going to use the sign rules that we learned when we were factoring trinomials. This second sign being positive tells us the signs are the same. And the first sign tells us what they are, so they're both positive. Now let's check to make sure that worked. Okay, so here's our check. First, 25x squared. Outside 35x. Inside 35x. And last 49. And when we combine those two middle terms there, we get the 70x, which is mainly what you need to check, is that your outside and inside are going to add up to that middle term. So it is correct. You can leave it like this, or because it's the same factor twice, you could write it as 5x plus 7 squared. And there will be times when we need to write it that way. Here in this section, either way is fine. So this, factoring it using the square roots, is shorter than had we done the AC method. If we did AC, we'd have to multiply 25 times 49, which is going to give you a large number to try to determine what factors work. Now certainly you can do it that way, but if you can recognize that it's a perfect square trinomial, this is a nice shortcut to use. Look at number 12. So we've got 64x squared, perfect square in front, 1 perfect square in back, and we've got that plus sign there that we need. So let's go to our parentheses. Square root of 64x squared is 8x. Square root of 1 is 1. Same signs, this time both minus. And then we just need to check to make sure we're going to get that negative 16x in the middle. If we were to multiply the outside, it'd be negative 8x, and the inside would be negative 8x. Together, those would add to negative 16x, which is what we have in the middle. Therefore, it works. Okay. Let's move on to cubes. Here is a short list of numbers that are perfect cubes and variables. So let's start on the left side with the numbers. 1 is a perfect cube because if you take 1 times 1 times 1, you get 1. 8 is a perfect cube because you get it from 2 times 2 times 2, and of course we could keep going down through the list. Same thing for variables. X cubed would be x times x times x. X to the 6, x squared times x squared times x squared. And we also want to be familiar with the term cube root. I would say the cube root of 27 is 3. We could say the cube root of x to the 6 is x squared. Now, when we have a polynomial that has only 2 terms in it, if they are both perfect cubes, we can factor it no matter what the sign is. If it's a difference of cubes, we can factor it. If it's a sum of cubes, we can factor it using a formula. So for these, you really kind of need to memorize the formula. They are very similar. Something that might help you just to remember the signs. Let's start with the top, the difference of cubes. So in the polynomial that you're given, if it's a minus sign, you're going to start your formula with a minus sign. So it's the same sign. Okay, I'm going to write that here. Same. The next sign is opposite of that first sign. So same, opposite. And the last sign is always, oops, let's see if I can use my eraser here. Okay, always positive. Sometimes people like to remember that as soap. Same, opposite, always positive. And that should help you remember the signs. Notice it also works for the addition. If it's a sum of cubes, then you start with the same sign, opposite sign, and always positive. You will still have to memorize the AB, the A squared, AB, and B squared. But if you do your homework, by the time you finish, if you write down that formula on every problem, you should have it memorized. Let's try some examples. So number 13, we've got an x cubed, which is a perfect cube, and a 64 is a perfect cube. So that short list that we had, let me go back to it real quick. 1, 8, 27, 64, 125, 216. I would memorize at least that many perfect cubes so that when you see these in a polynomial, you recognize them as perfect cubes. Now, 64 is special because it is both a perfect square and a perfect cube. Because the x cubed is a perfect cube, that's why we're thinking of 64 as a perfect cube here and not a square. So we've got perfect cubes with an addition sign in between. So we're looking at the sum of cubes formula. If it's helpful to you, you can write it down with the A's and B's in it. I'll go ahead and do that here. So A, same sign, so A plus B, open, and it's A squared, opposite sign, and then it's AB, always positive, B squared. So that's the formula we're going to use. Now, the A and the B are the cube roots of the 2 terms in the polynomial. So you may want to kind of go out to the side and write that. I'm going to here. So we've got A is the cube root. I'm going to write it out this time. Cube root of x cubed, which is x. And B is the cube root of 64, and that number is 4 because 4 times 4 times 4 is 64. So A is x and B is 4. Now all we have to do is substitute those into our formula. So in place of a, I'm going to put x. In place of b, I'm going to put 4. And then a squared becomes x squared. ab is x times 4, but when we multiply a number and variable, we want to put the number first. So let's put 4x. And b squared is 4 squared. So instead of writing 4 squared, go ahead and just put 16, the result of that exponent there. And that is our answer. Now you may be thinking, do I need to factor that trinomial on the next step? If it would factor, then yes, we would need to. However, we don't have any factors of 16 that add to be 4, so it will not factor. And it turns out that every time you use this formula, that trinomial will not factor further. So you can just plug in and stop right there. Let's go ahead and try another one. Look at 14. 27 and x cubed are both perfect cubes. 8 is a perfect cube. Let's go ahead. I'm kind of running out of room here. We'll write above it. A is going to be the cube root of 27x cubed. So that's going to be 3x. You have to cube root both the 27 and the x cubed. So a is 3x. B is the cube root of 8, which is 2. Do not put exponents on the a and b. So it's just 2. It's not 2 cubed. Then we're going to use the minus formula since we've got a minus in our polynomial. If you need to, write it down with the a's and the b's in it. So same sign, opposite sign, always positive. Substitute. In place of a, we put 3x. In place of b, we put 2. Now here, when we get to the part where we square a, we square both the number and the variable. So a is 3x. If I square 3x, 3 and x are multiplied, so that square goes on both, and it becomes 9x squared. And then a times b, we're going to actually multiply the 3 times 2 is 6 and put the x following that. And b squared is 2 squared, which is 4. Close, and there is our answer. So to factor perfect cubes, just memorize those formulas and remember SOAP, same, opposite, always, positive. So I'm actually going to go ahead and stop this video here, and you can practice with the perfect squares and cubes, and then I'll add one more factoring video that shows that general strategy.